In the November 1997 program, MasterTech introduced you to a new Chrysler Vehicle Communication Network, the Programmable Communication Interface, or PCI Bus. This network was first introduced on the Concorde, Intrepid, LHS, and 300M. The use of this bus system has now expanded to the 1999 Grand Cherokee, as well as to the 2000 Neon. Welcome to this month's MasterTech. In the first MasterTech program on the PCI bus, we said that the use of this system would expand to other models, and now it has. The purpose of this PCI bus update is to show you what components are on the PCI bus, how these components operate, and how to diagnose the system. Then we'll use that knowledge to fix the cluster on a Neon that is not working properly, and to diagnose and repair a Grand Cherokee that has multiple symptoms. In this segment, we're going to review PCI bus components in operation. One of the main characteristics of the PCI bus is that instead of the 2 wires that the CCD bus uses, the PCI bus uses a single wire to link each module or node on the network. The wire color used for the PCI bus is yellow with a violet tracer, or violet with a yellow tracer, depending on the application. In some cases, PCI bus wires may have an additional tracer color. The PCI bus uses low and high voltage levels to generate signals. Low voltage is around 0 volts, and high voltage is around 7.5 volts. The low and high voltage levels are generated by means of variable pulse width modulation to form signals of varying length. Besides the simplicity of a single wire, PCI bus advantages include a wider data band and a feature called an in-frame response, which allows the receiving module to attach a return message to the original message. Another advantage of the PCI bus system is that each module supplies voltage in termination. As a result, the bus can continue to operate even when there is an open circuit leading to one module. The November 1997 MasterTech covered the basics of PCI bus operation in detail. More information about bus operation is also available in basic electrical classes at your local training center. Now try this review question to check your knowledge about basic PCI bus operation. It's a good idea to stop the tape and discuss the answers to the question as well as the material in this segment before proceeding. Which of the following is not a feature of the PCI bus? A, variable pulse width modulation. B, single wire. C, a high voltage level of about 3 volts. Or D, voltage and termination at each module. The correct answer is C, a high voltage level of about 3 volts. It's true that the PCI bus uses pulse width modulation, a single wire, and voltage and termination at each module. However, the high voltage level is actually about 7.5 volts. In this segment, we're going to look at specific bus components according to vehicle. Let's begin with a review of the modules on the bus on the Concorde, Intrepid, LHS, and 300M. On these vehicles, the modules on the bus include the powertrain control module, transmission control module, controller anti-lock brake, airbag control module, Sentry key immobilizer module, mechanical instrument cluster, body control module, climate control module, radio, CD changer, overhead travel information system, and memory seat module. Notice that the DataLink connector is included in this and bus diagrams which follow. That's because the DataLink connector has a bus wire going to it that allows the DRB3 to communicate over the network. On the Concorde, Intrepid, LHS, and 300M, the body control module acts as a wiring hub for the bus, and so it serves as a central point for conducting bus diagnosis. On the Grand Cherokee, modules on the bus include the body control module, controller anti-lock brake, driver door module, memory and/or heated seats module, Electronic Vehicle Information Center, Transmission Control Module, Passenger Door Module, Sentry Key Immobilizer Module, Powertrain Control Module, CD Changer, Radio, Automatic Zone Control Module, Airbag Control Module, and Mechanical Instrument Cluster. A splice block connector called a diagnostic junction port acts as the wiring hub of the network and serves as a central point for bus diagnostics. On the Neon, modules on the PCI bus include the Sentry Key Immobilizer Module, Airbag Control Module, Powertrain Control Module, Remote Keyless Entry Module, Controller Anti-Lock Brake, and the Mechanical Instrument Cluster. On later production vehicles, the radio will also be on the bus. The Neon PCI bus system does not use a wiring hub. Even though all of the modules we've named have equal access to the bus, there are some differences in how much they use the bus and in their internal hardware. For example, usually the powertrain control module, transmission control module, and body control module are responsible for most of the traffic on the bus. Another feature of the PCI bus is that the network is designed to have one or more dominant modules or nodes which serve to stabilize the network in the event of problems. These dominant modules have a resistance in the neighborhood of 1,000 to 4,000 ohms. Non-dominant modules, on the other hand, have a resistance of about 10,000 to 11,000 ohms. On the Grand Cherokee, for example, the powertrain control module is one dominant module, and it has a resistance of 3,300 ohms. The mechanical instrument cluster is another dominant module with a resistance of 2,400 ohms. Now that we've looked at variations in the PCI bus according to vehicle, try this review question to check your knowledge. Which of the following serves as the wiring hub on the Jeep Grand Cherokee? A, Powertrain Control Module. B, Mechanical Instrument Cluster. C, both A and B. Or D, Diagnostic Junction Port. The correct answer is D, the Diagnostic Junction Port. On the Grand Cherokee, the Diagnostic Junction Port serves as the wiring hub and as an access point for diagnostics. In this segment of the PCI Bus Update, we're going to cover some of the things you need to keep in mind when diagnosing a PCI bus problem. The procedures you'll need to troubleshoot the PCI bus are on the MDS2 and in the body diagnostic procedures and service manuals. In the general information section of the diagnostic manuals under Communication, you'll find a summary of bus operation and diagnosis that provides a useful basis for finding the cause of bus problems. The diagnostic procedures on the MDS2 and in the manuals are similar to each other in format. These procedures are often updated, so make sure that you have the latest software installed on the MDS2 or the latest edition of the diagnostic manual. Using the procedures, you can troubleshoot on the basis of a diagnostic trouble code or on the basis of a symptom, and often a trouble code-based test can lead to a symptom test. One tool you'll need to troubleshoot the PCI bus is the DRB3 with the PEP module. You can check for diagnostic trouble codes with the DRB3 and use the PEP module's lab scope to check for bus activity. Because of its sampling rate, the lab scope is a better gauge of bus activity than the DRB multimeter. Speaking of multimeters, you'll need one to check the resistance of bus module hardware and to check bus circuitry for shorts and opens during troubleshooting. Two of the tools used during PCI bus troubleshooting, the J1962 Breakout Box and Special Tool 8339 Junction Port Tester, make it easier to gain access to bus circuits. On all models, the J1962 Breakout Box connects to the DataLink Connector to allow you to check the integrity of the DataLink Connector bus circuit and check the resistance between the DataLink and other bus components. On the 1999 Grand Cherokee, the Junction Port Tester connects to the Diagnostic Junction Port. and also connects the DRB3 to the vehicle. The tool allows you to access all bus circuits so you can quickly check bus activity, resistance, open circuits, and shorts to power or ground. The tools we've been discussing will help you isolate the cause of a bus problem, but they won't necessarily tell you that there's a problem with the bus in the first place. That's why it's important to become familiar with the signs that may point towards the bus as the source of a customer complaint. These signs can help determine whether you are looking at a complete bus failure or a partial bus failure. And in cases of partial bus failure, they can help direct you to the affected circuit. As we go through these symptoms, keep in mind that some can result from a number of causes and are not necessarily the result of a bus problem. One tip-off that there may be a bus problem is an obvious one: warning lamp illumination, or lamp illumination that is abnormal. For example, if the airbag warning lamp or the ABS and brake lamps are illuminated, it could indicate a problem with the airbag system or ABS, but it can also result from a breakdown in communication between the cluster and these systems. On vehicles with an electronically controlled transmission, if all of the Prindle segments are illuminated, it may indicate a breakdown in communication between the cluster and the transmission control module. If the cluster is backlit at full intensity without the headlamps on, it could indicate a breakdown in communication between the cluster and body control module on those vehicles equipped with a BCM. If all of the PCI controlled cluster lamps are illuminated, it could indicate a breakdown in communication between the cluster and all the other modules. On the Grand Cherokee, for instance, only the hazard and turn signal lamps are not controlled at all over the PCI bus. In each case, the symptom points you toward the part of the bus that may be responsible. Inoperative systems and components can also point towards a bus problem. When only PCI-controlled gauges are not operating, it could indicate a problem with bus communication. On Neon, all of the cluster functions except for the fuel gauge are controlled over the PCI bus. On vehicles with a Vehicle Information Center or system, dashed lines instead of a readout may indicate a breakdown in communication with the modules which supply it with information via the bus. A tip-off is that the compass, which is not dependent on the bus, still functions. The MDS2 and service manuals contain tests which indicate whether a lack of response may be bus-related. Lack of response to CD changer controls could indicate a breakdown in communication between the radio and CD changer. If the auto door locks or unlock on exit features of a power door lock system are not working, it could indicate a breakdown in communication between modules. A breakdown in bus communication can even affect vehicle starting. On a vehicle equipped with a Sentry key immobilizer system, a break in the PCI bus line between the SCIM and PCM while the key is off will prevent the vehicle from starting. In cases of a partial bus failure, you'll probably begin to see a pattern emerge in lamp illumination and inoperative components that indicates which part of the bus is the problem. In cases of a complete bus failure, you can expect to see multiple symptoms indicating a complete breakdown in communication between modules. Besides the symptoms we've looked at, a bus-related problem may also set various diagnostic trouble codes and cause the malfunction indicator lamp to stay on. In addition, on Neon, the words "no bus" in the odometer display can be an indication that the cluster has lost communication with the powertrain control module, airbag control module, and if equipped, the controller anti-lock brake. There are a few things to be aware of, however, concerning these indications and PCI bus diagnosis. For one thing, keep in mind that the name of a trouble code that results from a bus problem will not necessarily contain the word bus. Often, trouble codes will simply indicate that one module has not received messages from another one. For another thing, don't assume that a bus-related trouble code necessarily indicates a partial or complete bus failure. Trouble codes can result from, among other things, disconnecting modules with the key on. And anything that shuts down the operation of a control module can also cause that module not to communicate over the bus. So a complete diagnosis involves checking for opens and shorts, which may be affecting module operation. One way of following up on symptoms of bus failure is to check for a response from each module on the bus. If one of the modules on a vehicle is not present on a response list, it may indicate a partial bus failure. In this case, the cab is missing. Lack of response from all modules may indicate a complete bus failure. As with the symptoms and diagnostic trouble codes, it's important not to jump to conclusions when assessing lack of response. Keep in mind that a lack of response does not necessarily indicate that the bus is at fault. A number of other things can prevent a module from responding. Also keep in mind that a lack of response from the PCM may not be an indication of bus problems, since the PCM actually communicates with the DRB3 over the serial communications interface, not the PCI bus line. If your analysis of the symptoms results in investigating the bus for a possible failure, there are several areas you'll need to concentrate on. Prominent among these are wiring and connector concerns. On connectors, make sure the terminal for the PCI bus wire is not pushed out or spread. When examining PCI bus wiring, keep in mind that a wire that is merely open affects the bus differently than a wire that is shorted to power or ground. A PCI bus wire that is open will affect only the module or modules that connect to the bus via that wire. A wire that is shorted to power or ground, on the other hand, will cause the entire bus network to fail. Problems within the bus hardware and the modules themselves can also cause partial or complete bus failure. In some cases, the bus communication problems are really the result of a problem in some other component or system on the vehicle. Low battery voltage is one such cause. So is electromagnetic interference from ignition components, actuators, or motors. We've covered a lot of material in this segment, so before we move on, it might be a good idea to review some of the main points. First, it's important to have the proper tools, including the DRB3 with its PEP module, the J1962 Breakout Box, and special tool 8339 to diagnose the PCI bus. Second, the specific symptom can help you determine whether a complete or partial bus failure has occurred, and in the cases of partial bus failure, where you need to concentrate your efforts. Keep in mind, however, that many symptoms can have multiple causes, and that the bus is not necessarily at fault. Many bus-related diagnostic trouble codes can also have multiple causes and do not necessarily indicate a bus failure. Finally, possible causes of partial and complete bus failure include bus network components such as wiring, and components and systems that interfere with bus operation. Now try this review question to check your knowledge of bus diagnosis. Which of the following is an indication that a breakdown in bus communication may have occurred? A, dashed lines instead of a temperature readout in the EVIC. B, abnormal cluster lamp illumination. C, a no start on a Sentry key-equipped vehicle. Or D, all of the above. The correct answer is D, all of the above. All of these symptoms may indicate that there's a problem in the PCI bus. At this point, let's put what we've covered so far into practice with a sample problem on a Neon and a Grand Cherokee. The Neon has been brought into the dealership because in the instrument cluster, only the fuel gauge seems to be working properly, and the odometer display has a no bus readout. As we learned earlier, all of the cluster functions except for the fuel gauge are controlled over the PCI bus. The technician first confirms that the conditions described still exist. Based on the symptoms, he decides to use the procedure bus signals open from instrument cluster. The first step in this procedure involves checking the cluster fuse. Remember that we said that anything that shuts down a module can prevent communication. With the ignition off, the technician pulls the fuse, which appears to be in good shape. So the procedure directs him to check the IOD fuse in the power distribution center. This fuse also appears to be in good shape. Actually, if this fuse were open, the technician could have expected to see fuse in the cluster odometer display. Since the fuse is intact, the procedure directs him to the next step, which is checking the integrity of the cluster ground circuit at the cluster connector. A check of the resistance between the cluster ground circuit and a chassis ground shows continuity. Since the ground is intact, the procedure directs him to next check the fused ignition switch output at the cluster connector with the ignition on. A check of the feed from the ignition shows that there is no problem between the cluster fuse and the connector. So the procedure directs him to next check the fused B+ circuit at the cluster connector. The circuit from the battery is also providing the cluster with power, so the circuit between the fuse and the cluster connector is intact. Since there is no problem with the cluster ground or power, the procedure next directs the technician to check other modules for bus activity. Since all modules on the bus except for the cluster are responding, it means that the only part of the bus affected is related to the cluster. Otherwise, the technician would have had to investigate a complete bus failure. At this point, further investigation of the bus involves using the lab scope to check for bus activity. To do this, the technician selects the 12-volt square wave option. He then selects the scope option and sets the range at 20 volts using the F2 button. The procedure then directs him to probe the cluster connector bus terminal with the red lead while connecting the black lead to ground. Once the key is turned to the on position, there should be some activity on the lab scope in the form of pulses from 0 to about 7.5 volts. The lack of activity here indicates an open bus line. As a result, the procedure directs the technician to check the bus circuit for an open. The wiring diagrams indicate that the cluster's bus circuit ties into the rest of the bus network at splice S217, and that this splice is located on top of the instrument panel. After examining the wiring harness, the technician discovers the cause of the open. The bus wire has broken away from the splice. After repairing the wire, he verifies that the symptoms are gone, including the no bus readout on the odometer display. As part of the verification, he erases any diagnostic trouble codes. Then he starts the car and runs it for 2 minutes to allow time for any codes to reset. There are none, so the repair is complete. Next, we're going to move on to a Grand Cherokee with a bus problem. Before we do, however, try this review question. To check for bus activity on a neon, you can use A, Special Tool 8339, B, a voltmeter, C, an ohm meter, or D, the DRB3 lab scope. The correct answer is D, the DRB3 lab scope. You should use the DRB3 lab scope to check for bus activity. The Grand Cherokee in our sample problem was brought in with multiple symptoms, including an instrument cluster with warning lamps that stay on, incorrect backlighting, and gauges that don't work. Other symptoms include an EVIC that displays dashed lines instead of a temperature readout, and a number of bus-dependent systems that are not operating properly. In checking for related symptoms, the technician finds that non-bus-related items seem to be unaffected. Based on the extent of the bus-related items affected, the technician decides to use the procedure for PCI bus communication failure to isolate the cause. The procedure first directs him to connect the diagnostic junction port tester to the DRB3 and to the diagnostic junction port. He then selects Junction Port Tool and PCI Bus Module Scan and attempts to communicate with the modules on the bus. He is not able to communicate with any of the modules, so the procedure directs him to check the resistance of the bus circuit between the DataLink Connector and the diagnostic junction port tester to make sure an open is not causing the lack of response. The check between Terminal 2 of the DataLink Connector and Terminal 9 of the diagnostic junction port tester shows the circuit to be intact. So the procedure next asks the technician to use the DRB3 with the diagnostic junction port tester to test the bus circuits one at a time for a response. To do this, he selects Junction Port Tool and then PCI Bus Control Mode and follows the prompts. All of the pins respond except for pin 5, which the airbag control module is on. At this point, with the help of the DRB3 and diagnostic junction port tester, the technician has isolated the trouble to the bus circuit for the airbag control module. Next, he needs to locate the cause of the circuit failure. To do this, with the DRB3 disconnected, he turns the ignition on and checks the circuit for voltage as directed by the procedure. The voltage reading is 0, indicating that the cause of the problem is not a short to voltage, but could be a short to ground. To isolate the cause further, the technician will have to find out if the circuit or the module is at fault. To do this, he first disconnects the negative battery cable and then measures the resistance between pin 5 and ground. The resistance is under 100 ohms, indicating a short to ground. So the next step is to disconnect the airbag control module connector. If the resistance changes, the module is at fault. Upon removing the console, however, he notices that the meter reading changes. When he examines the wiring harness, the technician discovers that the PCI bus wire has been abraded and was probably contacting ground. The technician repairs the damaged wire, and as on the Neon, he performs the body verification test. And as with the Neon, the trouble codes do not reappear and all of the symptoms are gone. Before we wrap things up on this MasterTech, let's try one more review question concerning the tools we've looked at. To use the PCI bus control mode during diagnosis, you need to use A, only the diagnostic junction port tester, B, the diagnostic junction port tester and the DRB3, C, only the DRB3, or D, none of the above. The correct answer is B, the diagnostic junction port tester and the DRB3. To use the PCI bus control mode, you need to hook up both of these tools. The bus control mode allows you to check individual bus circuits for a response. That brings us to the close of another MasterTech program. As we've seen, bus diagnosis really depends on a few basics: a knowledge of bus systems on vehicles, the proper tools, and a methodical approach. Be sure to join us again next month on MasterTech when the topic will be non-destructive paint repair.